Previously on HVACR videos.
This line set right here is my walk-in box because it's running, and like you can see where it's rubbing against that pipe. That's something we need to check. So we're gonna make our way all the way down there to the walk-in coils. So remember I said knowing your restaurants and where the lines are running, I kind of have an idea. Follow this over. Look at that, liquid line solenoid valve with oil all around it. So let's have a look at that and get some soap bubbles on it and see what's going on. Anytime you use these, throw something in there so it doesn't burn itself out. It's not currently calling, but if you look right here, sprayed some soap bubbles right there. Look at that. Big old fat refrigerant leak right on that guy. So we need to change out that liquid line solenoid valve.
This video is brought to you by Heatcraft Refrigeration.
All right, it is time to replace these evaporator coils. They've got leaks in them. Took a while to get them ordered and shipped out and everything, but we got them now. We're going in with two like-for-like coils, just the new ones have intelligent. So we should be able to utilize the existing drain connections, hopefully. We gotta get up top and get the gas recovered first. All right, this is a system that we've worked on recently. We fixed the liquid line solenoid valve up on the roof, replaced it, put a new dryer and sight glass. So now we're gonna get recovering the gas out of here, and we are converting this system over to 448A. So shouldn't be too big of a deal. It's just got to get the gas recovered first. Okay, the recovery is running. I'm heading downstairs to get unhooking on the evaporator coils. The guys will get this all taken care of up here, and then once they give me the all clear, we'll put some nitro flowing up here, and then we'll start unsweating the coils and get the new coils put in. All right, I am up top. We got temporary screws put in the coils. We got to get these bolts out, 6 of them for each coil, and then we'll have to get up here, cut out the solenoid valve, and then, you know, do our thing. All right, got both the coils unsweat, ready to go. Drain lines unhooked. We're gonna drop them and then hang the new coils. We opened the walk-in freezer door for a few minutes, let it cool down the box because we got the coils shut off. Just, we won't leave it open the whole time, but just cooling down the box a little bit. All right, we got the 2 new coils, and the old one has an electrical hole that we got to measure out and drill. We got to drill that out. So I'm going to work on that right now. The guys are going to get the other coil down. We got this section, the solenoid taken out. We still got to do some electrical work up here. Last minute, this box was in the way, so we had to yank it up. We'll fix it. Now we're sending the bolts up, so we got to put the nuts on this end and tighten them from here. Okay, we got both the coils hung, and it's time to braze in the lines. So I hooked up the nitro. We're flowing through right now, and we're going to go get those things brazed up. All right, working on the piping. Now this unit doesn't have a P-trap. There's a little bit of oil vapor in there, but it's only about a 6-foot rise from here, so we're not going to install them. We don't need to. They haven't had them forever. We're just mocking everything up right here, and we're not going to braze until we got them both mocked up. That way the nitrogen's truly flowing through them. All right, got both the coils refrigeration lines sweat in, so they're good to go. I'm heading up to do the vacuum. Will's working on the comm line because we have to have a comm line running between both coils, and then we're going to use shielded cable. We're only going to shield one end, and then we're just going to get ready to start turning this guy on. We still got more electrical and drain line work to do, but I got to get the vacuum and the dryer changed. All right, it is pushing from suction out to here. We can test it by doing this. So we've been sweeping the whole time. That's what we want. And now we're going to hook up the vacuum pump. We got to change the dryer actually first real quick, but I'm going to change that, then we're going to hook up the vacuum pump on these 2 lines, hopefully, and get this guy pulling down. Okay, so this guy has a copper gasket inside of it. Make sure the copper gasket's still in there. Put a little bit of nylog right here, which I already did, okay? And then I like to use just a skosh on the threads. Now, some people don't, some people do. This is nylog blue. It's polyester oil. Oh, shoot. That's a 1/2 inch. I grabbed a 3/8. I need to go to my van and get the right one. I screwed up. Okay, so we're gonna just basically put a little bit of nylog right here on the seat, a tiny bit on the threads, thread the dryer on, use this guy. Thing, a little bit right here, a little bit on the threads, and then we're just going to hook it back up. All right. sight glass and the dryer are facing that way. We're going to tighten them on. Using my precision torque wrench. Click, did you hear it? Perfect. Okay, dryer's installed. We're gonna start pulling the evacuation now. Okay, gas ballast open, vacuum pump on. And we got the micron gauge on the other end. We're gonna watch it till it gets about 2,000-ish microns, and then we're gonna shut the gas ballast and let it continue evacuating. All right, well, we got some 448A stickers on there. It's not ideal, doesn't look like absolutely perfect, but we got enough. Microns, we're down to 426 microns. And you don't really want to look at my ugly face, but all right, we're gonna basically get ready to turn off the vacuum pump and get ready to charge this guy up so long as it holds. All right, and this is the beauty of Intelligen, is we should just be able to do everything from this one. I believe the expert pin is all 9s. Configure from evaporator, yes. Discovering equipment. 2 evaporators found, continue. We're going to change it to cooler 1A. Address of the other one is going to be cooler 1B. Primary evaporator is cooler 1A. That's this one. That's correct. Condensing unit wired? No. United States. Daylight savings. I'm going to set the time. 25. We'll get this set up right now. June, what's today, 9th? Yep. June 9th, and it is 12. And it's 42 p.m. Go. We're R448A. There we go. EXV Corel, air defrost, time defrost, box temp 35, start system. Okie dokie. Here we go. This guy's running, and now we're charging. So I'm weighing the gas as we're going in, charging it with 448A. And get the sight glass cleared up, and then we'll move from there. The system was shutting off on low pressure, so I just bypassed the low pressure control. It was pulling down to like 14, 15 PSI. We're just charging it up, so I just got to do that just to get some gas in it. Once we get about 5-6 pounds, it should run by itself, but it'll just take a little bit. Plus those EEVs are probably pretty wide open at the moment. You can see we're at about 5 pounds now, and now it's not shutting off on low pressure anymore. So we're just gonna keep charging it up. Sight glass is flashing at the moment. This guy's gonna take about 14 pounds of gas total. So we'll just weigh it in, make sure the sight glass is clear, and that should be enough for our head pressure control valve too. I ran out of refrigerant. I put 10 pounds in from my other drum. I just went and got a new drum. So now we're at 12 pounds. So we're gonna go to 15 is what we're gonna go to. But I'm noticing my head pressure's creeping up. Look under here. My condenser's plugged, so lovely. I gotta clean that too. So I'm gonna keep putting the gas in here. We'll get that cleaned up right now. Okay, we are looking good. It's about 80 degrees. We've got a nice clear sight glass. You can see we got a big Sporlan catch-all there and a big Sporlan see-all sight glass. So it's got about 7 degrees evaporator superheat for both evaporators. So this thing's coming down to temp. It's about to satisfy. And just simply brushing the condenser took it off. We've got someone with a vacuum right now pulling the rest of that stuff off. We are heading downstairs. We pulled the gauges off. This guy's looking great. We're finishing up the vacuuming of the rack, and we're just gonna go finish tidying up downstairs, putting all the panels on. All right, everything's looking good. This box is nice and cold. We're gonna come back in a day or two to follow up, just to make sure everything's good. So we'll check back in then. All right, came back out today, follow up on the equipment. It's running good. Box is down to temp. It's cold as heck in there. Sealed up all the penetrations. I still had 2 penetration holes I needed to seal up, which I knew it. I wanted to come back today anyway, so took care of that, just siliconed them up. Unit still running with a clear sight glass, all is well. You know, new technology, a lot of people are afraid of it, but there's no need to be afraid of it. We need to embrace it, okay? Forgive me if you hear my dogs running around. They're trying to get my attention right now. My Australian Shepherd wants me to throw her Frisbee for her. But new technology like intelligent, right? That's not even that new, but a lot of people are still afraid of it. There's no need to be afraid of that stuff, okay? You need to embrace it because there's more new tech coming into this trade right now than we've ever imagined. Just wait until CO2 comes into the light commercial sector, right? CO2 is prevalent in the heavy industrial and supermarket side, and it's inching its way into the light commercial sector. And when that comes, good gosh, if you're afraid of something like intelligent, wait till you have to start working on CO2 systems because they're pretty complex, okay? But back to this. So in this video, I took an existing system that needed new evaporator coils that lasted 20 years, which is great for systems like that, right? But it was time to upgrade the system, okay? So we put 2 new evaporator coils and we converted the system to 448A because 404A is on a short list, it's on a phase out list, and actually in the state of California where I'm at, you're not allowed to use 404A on major system retrofits or new system installs, okay? Repairs, you can still use 404A. You can keep an existing system going, but when it's time to upgrade the system, technically you're supposed to change the refrigerant. So the refrigerant that I've been using is 448A. I've had pretty good success with it. It does have a really high glide, which can kind of freak out a few people, especially when you're looking at the sight glass. You're not going to always see a super clear sight glass. The important thing to understand on 448A systems is that if my dog is being so funny. She got her Frisbee stuck on the other side of the yard. Here, I'm going to flip it around for you. She got her Frisbee right here, and she's waiting for me to throw it for her, but she pushed it onto this side of the gate and then was whining because she couldn't get to it and figured out how to get it back. So funny. She's like, "You're outside, Dad. Come play with me." All right. So anyways, so we converted the system to 448A, and it was a pretty straightforward conversion, okay? But the new evaporator coils were equipped with intelligent. Don't be afraid of intelligent. Intelligent is just Heatcraft's new iteration, and it's not even that new. It's been around for a couple years now, but it's their new evaporator digital control, essentially, okay? It eliminates the need for a liquid line solenoid valve if you don't want to use one. But the cool thing is if for some strange reason you have to use a liquid line solenoid valve, you can still add one because there's 2 dry contacts on the board that are capable of opening a liquid line solenoid valve if you want to, or closing it, whatever, right? So, but you don't need a liquid line solenoid valve. The EEV acts as the solenoid valve. It opens and closes fast enough that you can run the system just off the EEV, and that's the way that it was designed, okay? Intelligent has the ability of remote monitoring. Like, you guys have seen me use it. It's a pretty cool system, and it's super easy to set up and use, but you can basically do all sorts of different things if you hook up it to a local internet connection or a internet connection in general. The customer can have remote access to their systems, adding the web server card to it. You can do all sorts of things with intelligent, and it's really cool. All right, but the important thing is don't be afraid of it, right? New technology's coming. Don't be afraid of this stuff. Embrace it. Learn with it. I get it. There's the old school techs that just want to go back to old school when they just had a basic TXV and systems worked and we used R12 or we used R22 or whatever, insert thing that I see on social media all the time. But here's the thing. The people that are complaining that they want the good old days with R12, it's never going to happen. Period. Not going to happen. Same thing with R22. It's not going to happen. It's gone. 404A, it's out the door. It's going out the door too. Understand something. In refrigeration, if you've been in it long enough, I've been in it for quite a while. I was raised in this trade, right? Because I'm second generation. I remember still working on R12 systems. I remember now, obviously I was super young, but I remember working on it, right? And, the evolution of things change, right? And refrigerants, there's going to be a new flavor. There is a new flavor every single day. Okay. Stop obsessing about numbers like pressures and start paying attention to temperatures, because if you pay attention to temperatures, then when you change from refrigerant to refrigerant, you're just looking at temperatures. You're not so much obsessed with numbers. The numbers and the pressures come into play when you're setting pressure controls. And talking about pressure controls, this is a really important thing to understand with an intelligent system, is that with intelligent, you have to make sure that your pressure control is set correctly, especially if you're working with a scroll compressor. In the situation of this video, I had an older, I think it was like a ZB14 Copeland scroll compressor, maybe a ZS14, whatever it was. It was a 14 in the model number. But anyways, the pressure control is very important that it is set appropriately. Now, this was a walk-in cooler, so it's not as much of an issue. But when you get into low temp situations, there's some things you need to really think about. Number one, low temp or medium temp, is that with intelligent, you cannot have time delays. Okay, there cannot be a time delay preventing the compressor from turning on or from turning off too fast. Okay, but especially, and the reason why I say that is because Copeland out there has some tech bulletins that they want you to add time delays on the low temp compressors if you're having short cycling issues, because you have to set the pressure control so low. The internal bypass in the compressor, when it goes to pump down, will relieve the pressure, dumps the gas back into the suction side, then it instantly turns the compressor back on. You hear that ka-choo sound when it goes to pump down. It shuts off and then it turns back on, and then it shuts off and then it turns back on. Copeland has a tech bulletin that they want you to add. They want you to adjust the pressure control, and they want you to add a time delay to it. Well, that time delay does not work with intelligent. Okay, now if you have a communicating system, a beacon system, that's different. There's sometimes time delays on there. It's a totally different thing. But on intelligent, when you're not communicating with the condensing unit on the roof, you cannot have a time delay in between the contactor and the low pressure control. That is imperative. Okay, if you do have a low temperature system and you're having issues setting the pressure control because of long line sets or different things like that, and you're having the short cycling on and off, there's some remedies you can do. You can actually add a suction check valve to the system, and the placement of the pressure control and the suction check valve, make sure that the pressure control's on the other side of the suction check valve. And then that way, if the compressor does relieve that internal pressure, the gas will come back through to the suction side, then it stops at the suction check valve, right? Because the check valve only lets the refrigerant go through one way. The pressure control's on the other side of the check valve. You can eliminate that problem. So in low temp situations, you might have to add that check valve depending on, the pressure drop in your system and the line set length and stuff. But for the most part, I, don't really run into many issues with intelligent. But it's also important to understand too, that stuff does break, okay? So this system, I installed it probably, I don't know if it said it in the video or not. Or I'm sorry, I'm thinking of another system. But I have had some issues with the intelligent stuff, but it's all just basic stuff. Like the other day, the video that I was thinking in my head, I just shot another video where I had an EEV stator that failed, okay? But the really cool thing is that if you take the time and you invest in yourself and you go through the training that Heatcraft offers, especially the certified contractor program, they supply you with all sorts of great information, of which you can find too, but you get it all consolidated into one good area, and then it allows you to be more proficient with the equipment you're working on, okay? So again, I'm not the best service technician. I don't know everything about Heatcraft products, but I'm pretty confident in working on them, and I'm pretty comfortable with it, okay? So I appreciate you guys making it to the end of the video. This, was a part 2 kind of, because the initial video was a couple months back where we had a liquid line solenoid valve that failed. It was leaking. I had to change the liquid line solenoid valve, but I believe I mentioned in the video, and I believe it was actually in that one, that, we ordered new coils, but they took a while to get. And then I got busy, right? It wasn't just because it was probably like a 3-month period in between when the original service call was and me changing these coils. That had nothing to do with Heatcraft. I got those coils within like 2 weeks, 3 weeks or something like that of special ordering them from the factory. Then I just got busy and didn't have an opportunity to get back here. It wasn't a priority because the system was working. And then finally I got to it and you guys saw the change out. So nothing too crazy. Had my guys help me out, and we've kind of got these down to a cookie cutter approach. But it's important to understand that when you're installing these systems, just follow the manufacturer's installation instructions, okay? One last bit that I'm going to give you about Intelligen or the predecessor QRC is that follow the installation instructions to a T. One of the big things that people don't understand when you're converting a system that is existing, especially low temp systems, is that oftentimes on the light commercial side, our condensing unit powers the evaporator coil. But with Intelligent and its predecessor, or is it predecessor? Is that the right word? I might have said that wrong. But the previous one, which was QRC, if you read the installation instructions, it actually says that they do not want you powering the evaporator coil off of the condensing unit. They want a separate power source for the evaporator and for the condensing unit. So keep that in mind when you're doing the install, but just try to follow the manufacturer's instructions. It's really not that difficult. They're pretty easy to set up, as you guys saw in this. I mean, I'm not a genius and I can figure it out, so it's not too bad. I really appreciate you making it to the end of the video. Thank you so very much. Remember, don't be afraid of new technology. Embrace it, learn, grow, and be ready for the future. That's the cool thing about this trade, is that for the most part, you know, robots aren't going to replace us. AI is not going to replace us. AI might help us, and robots might aid in what we're doing in the future, but someone still has to fix the robots. That's us. So don't be afraid of new technology. Embrace it, grow with it, and be ready for it, because we need you to understand how to work on this stuff and the new stuff that's coming out tomorrow. You need to understand how to work on it, because, you know, as I get older and as people older than me get older and start aging out in this trade, we're going to need people to replace us. And we need people to help us right now too. So not just replace me, but I need people to help me. Don't be afraid of technology. Embrace it. Grow with it. Make yourself valuable. The knowledge that you gain is yours to keep forever, and nobody can take that from you. So keep that in mind. I really appreciate you making it. If you're interested in supporting the channel, there's a couple different ways to do so, but you know, the easiest way to support this channel is literally just watch these videos from beginning to end. That really is the easiest way. But you can support it financially by going to PayPal, Patreon, YouTube channel memberships. There's links in the show notes. Those are all just different ways that you can choose to make a monthly commitment or a reoccurring commitment to the channel. Or even a one-time commitment, you know. You can also support the channel by going to my website, HVACRvideos.com, where we have merchandise such as these hats available. Another great way. Those are shipped from our home. My wife handles all the merch orders and merch sales, so you're supporting a small family business by going to HVACRvideos.com. And last but not least, if you're interested in purchasing any tools, you saw me using anything in this video, the S-Man 480V manifold, let's see, I use the field piece meter, the S-Man, the SC480 is the meter. The S-Man 480 is the manifold, I think, that I used in this. But anyways, the SC480 is my digital meter. I picked that all up from SureTechTools.com. I actually have an affiliate program set up with them. If you use my affiliate code at checkout, which is Big Picture, that's 2 words put together. So Big Picture, 1 word, no spaces, okay? If you use Big Picture at checkout on majority of the items on their website, you get a discount, I get a small commission. It's a win-win. Thanks so much. I really do appreciate you, and hope to catch you on the next one.